Okay, finally, Chang'e-6 soil sample came back from Moon, and I'm not sure why China took time to do this. It was a couple of weeks ago. They did rendezvous and passed the sample to the returner, and returner came close to Earth. Then what the returner does is release the capsule. You see the capsule here? Okay. And returner is going to burn in the atmosphere. So only capsule arrive on the ground. And this has a sample from Itoken, flat, which is the south pole of the moon. And now, this is the second time China brought the sample back. Chang'e-5, the sample mission. From farther side of the moon. And this time, Chang'e-6 is, this was a far side of the moon, and this is a far side south pole. And China thinks the south pole is the candidate for building the human station, because south pole, the temperature variation is relatively low. Because the temperature go up and down, sometimes minus 199 all the way to 200, and they come down on the moon's surface. But if south pole, the sunlight is limited during the day, and nighttime you get some sunlight. All the time you get some sunlight. So the temperature variation is the less on the south pole and north pole. Okay, so south pole, the China wanted to study more about the south pole of the moon. Now, they didn't talk about this at all. The Chang'e-5, they talk about this a lot. How do you come back to Earth? Okay, its return flight, the V increase a lot because of the Earth's gravity. Okay, so V is very large. The Mach 20, somewhere around. And as you remember, mv square over r equals gravity constant and Earth's gravity and this capsule mass and r squared. So basically, in order to capture into the orbit properly, this has to be the condition. But this V is very large. Okay, that means the R is small, relatively small. This R is small, and there's an atmosphere right here. So if you capture directly, it's get into the atmosphere directly and burn really hard. Okay, and most of our capsule doesn't survive. This capsule you look at, it's burning, but it's less burning. What China does is they make R a little bit larger. R is this distance. So it's failed to capture properly. Okay, so it's come back and slightly pulled toward the Earth, but it's failed to capture, go back to the space. then it's come back and capture into the orbit, proper orbit. And this is called bouncing. Why you do this? The bouncing, actually, if you look at the height from Earth, so this is Earth, it's come back and get close here, closest point, then go back to space and come back. So it's like you throw a flat stone onto the water surface. It's bounce up and come back. Okay, so that's why it's like a stone bouncing on the water. But actually, this look like this after you flatten the Earth's surface like that. Actually, Earth is round, and it's not really bouncing. It's just passing Earth and overpass. And during that time, R is larger, so this gravity effect is lower. Here, the gravity effect is lower because for the speed v. Okay, then gradually come back and capture into the orbit. So this process, there's the atmosphere right here, and it's going to slow down. So here the v dash is much smaller than v. Okay, so that's the way you reduce the heat generation due to the atmosphere. You have to somehow reduce the speed, and this is kind of a braking mechanism. Its proper name is braking. It's not bouncing. It's braking mechanism. It's called a brake. It's missed to capture properly. It's just a slightly larger R, the less gravity, and let the V win. The V win, so it's jump out of the orbit and come back. Second time, when V is lower, it's come back to the proper orbit. So that's what China does. This did this in Chang'e-5, and probably they did it in Chang'e-6. If you don't do this, it's burn all of them, and you cannot retrieve anything. And that kind of things is not written in the Apollo at all. Probably they didn't know. NASA doesn't know this kind of things. This effect is severe. The V goes too high because of the Earth's gravity, and it's speed up too much. You need a braking process. You brake, reduce the speed, then you get into the orbit, and from orbit you select the timing to come down orbit and use a parachute to land in the Mongolia, inner Mongolia. So this process, braking process, always needed in order to reduce the heat generation due to atmosphere. And this already burn a lot outside. This is a heat resistance material, this capsule. But still temperature goes up really high. And if you don't do this, it's probably burn out. Even temperature heat resistance material cannot survive. Okay, so this is the process used for any return material from the space. The gravity effect is too large. Earth's gravity pull and increase the speed too much. So that's the kind of process they go through to retrieve. And we have to give some time to see what they discovered in South Pole soil. It's different from the soil from the far side of the moon. The far side it's also called dark side, but it's not dark. It's become day and night. It's repeat, just like a nearsighted. It's probably better name is near side and far side. The far side is always far side. The moon is made of two different density materials. The front side, near side, is a lighter material, calciums and others. The far side is more interesting. A lot of heavier material is on the far side. Okay, so that's the news for today. Okay, I keep reporting you the progress of the Chang'e-6. China is planning Chang'e-7 and 8 before they send men to the moon. So 2 more missions to build up the experience of sending something, landed, and come back. This whole process has to be repeated multiple times without failure before sending any men. Okay, so that's all for today.